Very good morning. We were dealing with the synthesis strategies for the preparation for Dienes preparation, and we have seen Dienes are of three types: isolated, conjugated, and cumulated. In Dienes, these conjugated Dienes are more stable than the cumulated Dienes or the isolated Dienes. The two factors attributes to this dienes or conjugated dienes, to be precise, stability. Hence, one of the factor is resonance stabilization. Another factor is more S character of the carbon. The carbon which are joined through a single bond is in sp2 hybrid form, which makes it more stronger carbon-carbon single bond and more shorter. And dienes, like alkenes, can undergo electrophilic addition reaction, as it also has the double bonds in it. And we know that electrophilic addition reaction is the characteristic reaction exhibited by alkenes. We have seen addition of hydrogen halides to alkenes, and we know that when it gets added up, it follows Markovnikov's or anti-Markovnikov's rule. Addition of hydrogen chloride or hydrogen iodide, it followed Markovnikov's rule, whereas addition of hydrogen bromide, it followed anti-Markovnikov's rule, which has been attributed to the presence of hydrogen peroxides or any other peroxides as impurities in it. Today's subject of discussion is addition of hydrogen bromides across the conjugated dienes. The simplest example for a conjugated diene is butadiene, or precisely 1,3 butadiene. When HBr adds up to the carbon-carbon double bond, H plus and Br minus, the H plus can act as an electrophile and it creates the disturbance in the pi electrons distribution between the two carbons because of the electromeric effect. The hydrogen bromide and butadiene, when it is reacted at minus 80 degrees centigrade, the pi electrons moves towards one carbon because of the electromeric effect created by the H plus, an electrophile. The electron-rich carbon shares its electrons with the H plus and it forms the bond and bromide ion gets kicked off. When this is formed, we get a secondary carbocation, and this is found in preference because secondary carbocations are more stable. Then onto this positive center, bromide ion attacks and I get 1,2 addition product to give rise to 3 bromo 1 butene. The yield of this is 80%. Electrophilic addition takes place when hydrogen bromide is added in one equivalent across the conjugated diene, and this follows Markovnikov's addition to give 1,2 addition product. The hydrogen and bromide ions are added at 1 and 2 position. That's why we call it as 1,2 addition product. But however, bromide ion attacks on this positive center. There is other possibility. The pi electrons adjacent to this carbocation can also move. to satisfy this positive center. Then it gives rise to a primary carbocation which is less stable. This is attributed to the resonance stabilization. Why the less stable carbocation is formed? Because of resonance effect from the allylic carbon. I'll get allylic carbocation. And bromide ion can also attack on this positive center, and it undergoes 1,4 addition. At one position H plus is added, at fourth position bromide ion gets added. I'll get corresponding 1 bromo 2 butene. In addition to this expected product 3 bromo 1 butene, which is the major product, I'll also get a minor product in 20%, the 1,4 addition product. Two possible products are possible. When this reaction takes place at minus 80 degrees centigrade. One is the major product, another is the minor product. Why these are not equally formed in equal ratio? Why this predominates? Why this 1 bromo 2 butane is the minor product? Let us look into the explanation of this. At lower temperature, this reaction is kinetically controlled. At means at low temperature, activation energy is less. That's why they produces the fastest forming product, that is 1, 2 addition product. The product is less stable, but it forms quicker. But the same reaction, when it is taken place at higher temperature, that is 40 degrees centigrade, I'll get 3 bromo 1 butene in 20% and 1 bromo 2 butene at 80%. The major product formed was 3 bromo 1 butene at minus 80 degrees centigrade, but it has become the minor product. Why is it so? The temperature has a profound effect. At higher temperature, the reaction is thermodynamically controlled. At higher temperature, dynamicity of the reaction increases. Why this dynamicity increases? They formed 1 3 bromo 1 butene, that is 1 2 addition product, is reversible because of the dynamism. Thermodynamic. At higher temperature, the dynamicity increases. The formed 3 bromo 1 butene can get converted into the secondary carbocation, and that secondary carbocation has more equilibrium towards the resonance stabilized carbocation, that is primary carbocation. As there is more dynamicity at higher temperature, 1,4 addition product will be formed, that is the resonance stabilized intermediate allylic carbocation is formed in more quantity, and that's why the 1,4 addition product predominates at higher temperature. Now you can appreciate the effect of the temperature on the reaction. At lower temperature, kinetics is less. The secondary carbocation conversion to the allylic carbocation is lesser. At that time, the bromide ion attacks on the secondary carbocation and that will become the major product. Whereas at higher temperature, dynamicity is increased. The secondary carbocation, which is formed as an intermediate, gets converted into a primary carbocation because of resonance stabilization. Resonance increases at higher temperature. It is as it is highly energetic, and hence 1,4 addition product predominates. The same reagent, the same starting material, at lower temperature, one product is formed in higher quantity, that is this is formed as a major product, but at the same time at higher temperature that is becomes the minor product which is formed. This is the uniqueness of this reaction of dienes with addition of with hydrogen bromide addition. And this also is found in other addition reactions too. And those will be the subject of discussion for the coming presentation. Till then, have a nice day. Thank you.